All right, so either you are in my 7th hour class and you are having to watch this video because I'm not here, I'm at a wrestling tournament, or you were in 2nd or 5th hour and we're gone on Friday, and so you still need the rest of the notes for lesson 6.5. So, whatever the case is, please pay attention. This video should finish up lesson 6.5 so that you're able to start working on that assignment. So, I'm going to quickly review the things covered in the first video. We were talking about rhombi, which is the plural of rhombus, and squares. So first of all, we talked about what a rhombus is. It's a parallelogram with 4 congruent sides. So if it's a rhombus, it has 4 congruent sides, not necessarily 4 congruent angles. We also looked at the fact that if it's a rhombus, then the diagonals are perpendicular. That means they intersect at right angles. And if it's a rhombus, the diagonals bisect opposite angles. And so I was able to show you that angles 1 and 2 are congruent, as are 3 and 4. And since it's a parallelogram and the opposite angles P and R are congruent, the bisected angles 1, 2, 3, and 4 are also congruent. All 4 of those are. Same for 5, 6, 7, and 8. Okay? Like a rectangle, a rhombus is a parallelogram, so you can apply all those properties of parallelograms to rhombi. Then we talked about example 1a, where we found our measurements using the bisected angles part of that. And then in 1b, the video went through using bisected angles and this right angle again to find the value of a, to plug into this, and found that that was 20 degrees. But then if you were watching carefully, you noticed that I made a mistake when I found b. I'd like to tell you that it was on purpose just so I could make sure you were watching the videos at home, but it wasn't. I actually just made a mistake. So for those of you that caught that, thank you for paying attention. For those of you that did watch the videos and didn't catch it, pay more attention, please. That's okay. So we're going to talk about what this should actually be, and then we're going to do part C on this next part, okay? So you'll notice the mistake I made when I subtracted 3b from both sides. 13b minus 3b is not 13b still. Okay, 13b minus 3b is 10b. So we should divide both sides by 10. And when we divide 13 by 10, I don't get b equals 1. I get b equals 1.3. And since b is 1.3, when I go to plug that in here, there's a second mistake I made, by the way. I'm going to do 3 times 1.3 plus 4. 3 times 1.3 is 3.9. When I add 3 and 4, I didn't get 12 anyway. I should have gotten 7. So 3.9 plus 4 is now 7.9. And that's the answer we should get for 1b. Okay? And so that's going to let us get started for 1c. We're going to go ahead and do that one together in the video, so be ready to follow along with 1c. Alright, part C, we're told CDFG is a rhombus. Okay? Remember everything we know about rhombi then. Congruent 4 sides. So all 4 sides are the same. That's going to help me find A, because I'm supposed to find CD and the measure of angle GCH. Now that is all going to come from this. So first we're going to find CD. Now if I'm moving too fast at all, you can raise your hand and have the sub pause the video just to make sure you get stuff copied down, or he can go back and show anything over. You get to hear my wonderful voice even more. I'm fine with that. So I'm going to go ahead and move forward again. If you need to pause at all, just have the substitute. I'm not exactly sure who they're having cover for me today. Just have them pause the video so you can copy stuff down. All right. We know to find CD first. CD is this side. But we know all 4 sides are congruent. That means once I know the value of A, I just plug it in and find that. If all 4 sides are congruent, then these two should be equal. So I'm going to start with 5a equals 3a plus 17, because CG and FG are equal. And then I'm going to subtract 3a from both sides to cancel it out there. We get 2a equals 17. And then we're going to divide both sides by 2. Hold on just a second. That should get rid of the glare. Sorry if you couldn't see that very well. We're going to divide both sides by 2 and get that a is 8.5. Okay, cancels that out. So A is 8.5. That means all of these sides are going to be equal to whatever 5 times 8.5 is. So CD is the same as CG, which is 5 times 8.5. So when I do 5 times 8.5, 42.5. And that is your answer for CD. Okay? Now we still have to find the measure of angle GCH. GCH. So this is what we're looking for, this angle measure here. So we're going to look at the given information about the other angles. We are told that GCD, this angle, the whole thing, is B plus 3. And we're told that CDF, this angle, is 6B minus 40. Now, we need to remember, in a rhombus is also a parallelogram. Angles C, right here, and D, that we've marked with these two, are not opposite angles, so they are not congruent. We do not want to say this equals this. But they are consecutive angles, and I need you to remember that consecutive angles are supplementary. That means that this value plus this value should equal a total of 180 degrees. So I'm going to say B plus 3 plus 6B minus 40 equals 180. Now, some of you might just combine like terms directly, and you might get 7B minus 37 equals 180. And then we simply solve for B. The first step is to cancel out the minus 37 by adding 37. We get 7B equals 217. And then we divide both sides by 7, and we get that B equals 31. But that's not your final answer. Remember, you want to plug that in to be able to find the measure of angle GCH. Now, GCH, you'll remember this diagonal CF, the segment that cuts through the middle of the rhombus there, it bisects these opposite angles C and F. That means whatever B plus 3 is, I'm going to cut that in half to get this angle GCH right there. So I'm going to find out that the measure of angle C here is 31 plus 3, which is 34 degrees. I'm going to cut that in half to get the measure of angle GCH. It'll end up being half of that 34. So I just divide by 2. Half of 34 is 17 degrees. Okay, so that finishes up example 1. Alright, and then we finished up with some more given information from the previous video, so I'm going to review that. We now started talking about what a square is. It's our fourth type of special quadrilateral. It's a square. A square is a parallelogram with 4 right angles and 4 congruent sides. Since it has 4 right angles, it's a rectangle. Since it has 4 congruent sides, it's a rhombus. That means a square is a parallelogram that is also a rectangle and a rhombus. We also call that a regular quadrilateral. So the square has the properties of all 3 of these. So all the properties we've put together are wrapped up in what a square is. Okay? And so then we started to take a look, sorry about that. We started to take a look at how to put this stuff on the graph and how to work with our formulas in a graph to verify that we have these properties of a square. And so here's what we worked through in the video. We plotted our points first, and we wanted to show that the diagonals of this square are congruent perpendicular bisectors of each other. If the diagonals are congruent, remember that means it's a rectangle. If the diagonals are perpendicular, that means it's a rhombus. And because they bisect each other, it's a parallelogram. Now, the first 2 parts that I showed you in the first video go over how to verify these two, how to verify that it is a rectangle and that it's a rhombus. And these are really the main 2 we're going to use in this lesson. And so we use our distance formula to show that they are congruent, meaning they have the same length. We use our slope formula to show that they have opposite reciprocal slopes. That means they're perpendicular. When we have opposite reciprocal slopes, these intersect at a 90-degree angle. That means it's a rhombus. The last thing that I want you to make sure you have written down, and again, if there needs to be some pausing of the video, we can do that. to verify that it is actually a parallelogram, you need to show that the diagonals bisect each other. And we've done that before by showing that they have the same midpoint. And so what I've done here is I've shown you how to find the midpoint of one diagonal, SV. The middle is the point 1/2, -3.5 when you plug it in. So if we need to pause, we can get that copied down. Then the midpoint of the other diagonal, using our midpoint formula here, is also 1/2, -3.5. So we do know that they bisect each other, which makes it a parallelogram. Since this is a parallelogram that is also a rectangle and a rhombus, we can say that it's a square. All right? All right, and that leads us to these conditions for something being a rhombi and then also a square. Now, this is pretty simple. It doesn't take a whole lot to copy this down. If we have a parallelogram with perpendicular diagonals, that means it's a rhombus. So I want you to write that down. Okay. Also, if we have a parallelogram where one diagonal bisects a pair of opposite angles, then it's a rhombus. So we can write that down. Okay. And then with this last one, we also know that if it's a parallelogram with a pair of consecutive sides that are also congruent, that makes it a rhombus. Okay, so these are the conditions for showing that something is in fact a rhombus, and we will use these diagonals being perpendicular in our coordinate geometry on the coordinate plane most of the time. And lastly, we have one condition for a quadrilateral being a square, and that's this. If a parallelogram is a rectangle and a rhombus, then it is a square. All right. Now, once again, if you need this video to go back to write anything else down, or if you need it to be paused, make sure you speak up, raise your hand. Don't want to leave any of this out. It will also be put on Edmodo later today, so that if you missed any of it, you can go back and get caught up with that. All right, we're going to fill out this graphic organizer kind of quickly. Again, this will be a pause situation to get everything written down if you need to. But we're going to, you have to excuse my imagination here a little bit, but I think it'll help make sense to you. We're going to pretend that we have a country called the country of quadrilaterals. And this is the border of our country, but within that country we have a state called parallelograms. And so we have this understanding that parallelograms, the state, is in the country of quadrilaterals. So if you're a parallelogram, you are a member of the quadrilaterals. It just happens that way. Okay? And so this Venn diagram is kind of a interesting way of showing that. But in the parallelograms, we have two separate regions of special parallelograms. One for rhombi and one for rectangles. All right? And these two regions have an overlapping region where if this region, people living in this region of the state, are both rhombi and rectangles. Those are the squares. Okay? So what I would like for you to do is to quickly write down the definitions for each of these terms in the spaces provided. And you can write anywhere in these regions you want, but I want you to get the definitions written down. If you need some extra time, I'm going to put it up on the screen so you see it, but then just pause it so you can copy it down. Okay, if we're ready to move on, there's one final thing I want to finish up with in this video. Okay, we're actually going to finish up with example 4a. Any of the other examples not covered, you don't have to make sure you get those copied down unless you just want to, and you can check with me when I get back. But what I want us to do is I want you to do example 4a, and I'm going to kind of show you the finished product to show you what it looks like. Okay, once again, you're going to want to pause this so you can take a look at it. We've plotted the points for our square, and we're going to use the diagonals. We can show the diagonals are congruent to show that it's a rectangle, and show that they are perpendicular to show that it's a rhombus.